These days, air temperature is something we can easily check on our phones or by simply stepping outside before deciding if we really need to wear t-shirt or sweaters. But air temperature's influence is so much more than what we wear. Global temperature patterns have long affected cultures and community decision-making in the landscape of plants and animals. What is air temperature? Temperature is a degree of hotness or coldness, and so air temperature is the measure of hotness or coldness of air. It is also termed as surface temperature in meteorology. Air temperature is the temperature indicated by the thermometer exposed to the air but sheltered from direct sun exposure. How is air temperature measured? It is measured with thermometers. Thermometers have a scale in degrees Fahrenheit or in degrees Celsius. Celsius scale is part of metric system used in most countries, and Fahrenheit scale is commonly used in United States. Air temperature varies from place to place. It does not remain the same everywhere. It varies from place to place because it depends on a large number of factors, such as the latitude and altitude of a place, distribution of land and sea, ocean currents, and vegetation cover. Here are some common important temperatures in both Celsius and Fahrenheit scales. The two temperature scales are equal at -40 degrees. Why is air temperature important? It is important because it affects the growth and production of plants and animals. It also affects the rate of evaporation, the relative humidity of a place, wind speed and direction, and also precipitation patterns. Most plants have growth season and life cycle that follows seasonal temperature variation of the environment. Very cold temperature may be associated with low availability of water since frozen water is not available for use by plants. As temperature gets warmer, many plants are starting to grow and bloom and survive longer than the cold season. However, temperatures above 40 degrees Celsius may cause damage to proteins and those above 75 degrees Celsius to chlorophyll pigment within the plants. Temperature is a prominent abiotic environmental variable that drives the adaptive trajectories of animal lineages and structure of composition of animal communities. Rising temperature may negatively affect animal fitness directly through effects on physiology. Animals that live in polar areas have to protect their bodies against extremely cold environment conditions. Their bodies cannot withstand such cold climates, so they have thick fur on their body. This provides additional layer over the skin. Animals living in hot regions have thick fur on top of the body for shade and thin fur elsewhere to allow easy heat loss. Relative humidity. Air in the atmosphere comprises of 78% nitrogen, 21% oxygen, and the remaining 1% comprises other gases. Molecules in air are not really interacting with each other. That means there is something else in the air too. That means there is space between those gases. So basically, we can put another molecule in spaces between these gases. So in relative humidity, we just simply think of as to the percentage of water vapor in the atmosphere compared to the vapor the atmosphere can hold at the temperature. Example, the bodies of water exposed under the sun, eventually it heats up. Water molecules in both air and water absorbs heat and will be in an excited state, which means more molecules are going fast enough to leave the water in form of evaporation. If the surrounding or the atmosphere is all filled with water molecules, then we say the air is saturated, so the humidity reaches 100%. And if there wasn't any water molecules in it, then we say that the relative humidity is zero. However, that never happens in nature. When it reaches the temperature when the relative humidity is 100%, where it can no longer be able to hold the amount of vapor, the temperature reaches the dew point. Then condensation can begin to occur, then precipitation happens. Take note that relative humidity is inversely proportional to temperature. So if temperature increases, then relative humidity decreases. And if temperature decreases, relative humidity increases. The temperature of air masses is an important factor that affects the wind. During daytime, solar radiation warms the land faster than it warms the sea. It also causes the air above the land to warm up. Warm air, being less dense, expands and rises, leaving the area of low pressure. On the other hand, air over the ocean is cooler. Cooler and denser air sinks over the water, creating an area of high pressure. The differences in the pressure and temperature creates a convection current. Warm air on land is replaced by cooler air, and this cold air is eventually warmed by the land and then rises, and the cycle continues. As a result, wind blows from sea to the coast and cold sea breeze. The opposite happens during nighttime. Cool air over the land becomes more dense, creating high pressure, while water, since it cools down slowly, the warm and less dense air rises, creating low pressure. So at night, cool air on land moves over the ocean. This air is warmed by the water and the cycle continues. And so at night time we call the air land breeze. As temperature rises, the air becomes warmer, more moisture evaporates from land and water into the atmosphere. More moisture in the air generally means we can expect more precipitation and more heavy downpours. Rain or snow are generally termed as precipitation. There are many types of precipitation, and these are orographic precipitation, frontal, and convectional precipitation. Orographic precipitation, also known as relief precipitation, is commonly found in coastal regions with a mountain range. Wind from the sea contains a lot of moisture, and when it reaches a mountain, it cannot continue and is forced upwards. As the air mass goes upward, it cools and eventually condenses into clouds. Soon after, the clouds can no longer hold any more water and it begins to rain. Most of the precipitation ends up on the side facing the ocean, called windward side, while the other, called leeward side, gets leeward. This causes one side to be moist and full of vegetation while the other side is dry. Next is frontal or cyclonic precipitation. When a warm, moist air mass meets a cold, dry air mass, the warm one rises and the water vapor in the warm air condenses as it rises, forming clouds. Eventually, it will rain. If it is a warm front, then the warm air will gradually rise, causing a mild to moderate prolonged rainfall. If it is a cold front, then the warm air will rise quickly, causing unstable weather conditions, including thunderstorms. Frontal rainfall is said to be common in British Islands. Next is convectional precipitation. On hot days, the sun hits the ground. The ground then releases some of the heat, which warms the air. That warm air rises and cools to condense water vapor into liquid. This causes rainfall to initiate instantly, usually without warnings. Another type of precipitation is convectional precipitation. Since convectional precipitation relies on the sun heating the ground, it is far more common in tropical regions where the sun hits at more direct and intense angle. During months of April and May, we usually notice the extreme heat, especially during afternoons, as compared to the other months. We have the feeling of alinsangan, but still we do not sweat. Here comes the concept of heat index. It is a basis in determining the temperature that a person feels affecting his body other than the air temperature. In other countries, heat index is also called feels like temperature, while in the Philippines, heat index is called init factor. In countries with winter seasons, they consider the wind chill and the air temperature in order to determine the feels like temperature. However, in tropical countries like the Philippines, where we experience hot season for almost a year, we consider the humidity or the relative humidity and air temperature to know the heat index temperature. Again, as I mentioned the earlier slide, so humidity is the amount of moisture or water vapor in the atmosphere in the form of water vapor. In Tagalog, it is called halumigmig or alinsangan. How can we relate relative humidity into heat index? If an individual sweat, water evaporates along with the sweating. In normal relative humidity, nababawasan yung init ng ating katawan at mas nagkakaroon tayo ng maginhawang pakiramdam. Usually, the air temperature in the surrounding is just or almost the same as feels like temperature. However, if we reaches abnormally high temperature, it is difficult for the atmosphere to accommodate more water vapor. This causes less sweating on the human body. This is the reason where the feels like temperature is higher as compared the temperature in the surroundings. Numerically, we can determine the temperature using the heat index table. In order to use the table, it is important for us to already have the values for relative humidity and the air temperature. Example, air temperature is at 38 degrees Celsius and the relative humidity is at 60%. So the heat index temperature is 55 degrees Celsius, which is 17 degrees higher compared to the air temperature. Here are the effects of heat index in our body. At 27 to 32 degrees Celsius, fatigue is possible with prolonged exposure and activity. Continuing activity could result to heat cramps. At 32 to 41 degrees Celsius, extreme caution heat cramps and heat exhaustion are available. At 41 to 54 degrees Celsius, danger heat cramps and heat exhaustion are likely. Heat stroke is probable with continued activity, and over 54 degrees Celsius, extreme danger heat stroke is imminent. Tips to beat the heat during summer. Stay indoor as much as possible. If air conditioning is not available, stay on the lowest floor, out of the sunshine. Wear lightweight and light-colored clothing. Drink plenty of water regularly. Water is the safest liquid to drink during heat emergencies. Avoid drinking liquor because it dehydrates the body. Eat small meals but eat more often. Avoid eating high-protein foods which can increase metabolic heat.